To another video, and today we're going to be working on the Unit 8 quick quiz. And so far we're going to go over question 8 first. So the reason we skipped to question 8 is just because Miss Fitz particularly thinks that this is a question that we should review, so I'm obviously going to go based off of that. But let's first look at this question. So I know this problem comes with like a lot more context, but for question 8 we're just going to focus on the actual like piecewise function right here. So this little thing, that is a piecewise function, and we know it's a piecewise function because it has this little like symbol right here, and we also have these inequality statements. So that's kind of like a given that it's a piecewise. So what I'm going to do and the way I'm going to label it is, first I'm going to label my y and my x axis. So I know, given the problem above this, or like the information to this problem, that this right here is going to represent my y axis, right here is going to represent my height. And then this right here is just going to be the horizontal position. Okay, cool. So now literally what I'm going to do is that based off of these points right here, I'm going to plug them all into this piecewise like function. So firstly, if my x value is 0, I'm going to use this equation right here, right? This is the equation that corresponds with all the x values between 0 and 2. And don't forget that since it has this like less than or equal to symbol, then that means if I'm given the number 2, that I'm going to plug it in to this one, not this one. Since this one does not have the less than or equal to symbol, then we don't include 2 in this one. Same thing with this one, we don't include 5 here. Instead we use 5 with this equation, because it tells us that it is less than 5 or equal to 5. Okay, so obviously I'm gonna start doing the math. Okay, so I'm just gonna plug in 0 for my x right here. So I'm just gonna like do it squared. And what I actually like to do is I just like to like write out the equation and then just put the parentheses and then add in my numbers. So that's 0 plus 4, that's 4. So just to keep track of everything, I'm actually going to make a little table like to the side. Plugged in 0 and we got out 4, and I'm just going to continue on from there. And then once again, when we're trying to find 2, we're going to use this equation because this is the one where it says less than or equal to 2. For this one, there's not an equal to 2 symbol, so we don't include 2 in this. If that makes sense. Like we don't use 2 for this equation, instead we use 2 with this equation. Alrighty, and so all I'm doing to find these values is plugging in whatever x value I'm trying to find here and plugging it into the equation that it corresponds to. So for example, if I'm trying to find what is the y value when my x is equal to 5, right? So if I'm trying to find g of 5, what I'm going to do is I'm going to plug in 5 to this equation right here, because it says use this equation for numbers that are greater than 2 or less than or equal to 5, right? This equal sign is really important right here, because if not, you wouldn't know which equation to use. And since it specifies that you are specifically using this equation when it's equal to 5, I just plug 5 into here, minus 2, that's 3. That's how we got all of these. So now I'm just going to plot everything onto this little graph right here. Alrighty, I plotted all my points, and now I'm gonna try to connect them in the straightest line possible. I honestly doubt it's gonna be that nicely connected, but you know, we're gonna try. Okay. Alrighty guys, and that's how we plot this. That's literally it. Now, you know, I'm just gonna go ahead and like help you guys out with question 9. So it's asking you what is the range, right? And I want you guys to remember that when we're talking about range, we're talking about y values, or you can also say we're talking about outputs. So we're referring to the outputs, we're looking at where are numbers on the y value, right? So what is the lowest y value that we get, and what is the largest y value that we get? So we know, if we look at our table, or like we could even just look at the graph, we know that the lowest y point that we're ever going to reach are these little zeros right here. So we know that it's going to be 0, comma something, and we're going to have the brackets because the points actually end up touching the zeros. when we use brackets, it's telling you like, hey, there's actually a point on this y value. Now, our highest y value that this graph ever reaches is this 4 right here. So it's just going to be 0, 4, and obviously we're going to have that bracket because it touches the actual like point at, like we actually get a 4 as an output. Now, also, I just want you guys to remember that when we're also referring to maximum and minimums, we're also referring to the y values, aka the outputs. So in this case, we're looking for the max y value that we're getting out, right? Like what is our biggest output that we're getting out? And obviously we actually said it earlier, it's just 4. So our maximum is going to be 4, and in this context we're using centimeters, so it's going to be centimeters. Actually, let me emphasize that this height is in centimeters. But yes, that's really it, guys. Just like to summarize, what you want to do is you want to look at the x values that you're trying to point. You're going to plug in the x values to the equation that it corresponds to, depending on what these like little inequalities say. And just remember to pay extra attention to if it says less than or equal to, or if it just says less than. And then you plot, and just remember range and minimum and maximum are all referring to the y values. Domain refers to the x values. Alrighty guys, let's go on to the next question. The next question. So here what we're trying to do is we're literally just trying to plot some points on this graph. And so honestly, I would say this is a pretty like simple equation. I would just say like to understand. So what we have here is p of x is equal to the negative absolute value of x plus 3 plus 2. So all we really have to do is we're just going to plug in whatever x values into this x to get out our y value or our output, if that makes sense. So I'm just going to start off with, 0, 1, 2, or 0, negative 1, negative 2, negative 3. And just to keep track of that, I'm going to make a little table because, we always want to keep track of what we're doing. At least I think that is, p of x. I always think that's so helpful because just like as you get on later into the maths, it genuinely is so helpful to keep track of what you know, what you don't know, and so on. Okay, so for example, let's start off, let's just start off with negative 1 just for like funsies. So we have negative 1. I'm going to do this in a different color just so it's obvious like what number we're working with. Okay, plus 3 plus 2. Okay, so we know negative 1 plus 3, that is 2. The absolute value of 2 is 2. That's going to become a negative because it said negative absolute value plus that 2, and it's going to be 0. So I'm just going to plug in 0, negative 1. Actually, guys, maybe I should go like backwards. Okay, you know what? I'm just going to do like 3, 2, 1, 0, negative 1, negative 2, negative 3, so on. Okay, so we know for negative 1, we have, it's 0. Okay, and then I'm just going to repeat that for other numbers, but I'm going to do like a couple more examples just so you guys can get like a feel of what it's like to use these like piecewise functions, particularly with the like absolute value. So I'm going to actually do 1 this time. So I'm going to do negative absolute value of 1 plus 3 absolute value plus 2. Okay, so we know that's 3. The absolute value of 3 is 3. We're going to add a negative to that plus a 2, and that becomes 1. So I'm going to add a 1 right here. And then we're just going to continue on to that pattern. So I'm going to fill out this table and we're going to come back. Okay, wait guys, I just realized something. This is not 1, this is negative 1. Okay, that is negative 1, right? Because negative 3 plus 2. Okay, so sorry. Okay, now this right here is the actual answer. I'm gonna go back and solve these and actually make sure I get the right answer this time. Okay, so what I'm gonna do here, guys, is I'm just gonna start plugging in values. I'm also gonna make a table just to keep track of all the values that I'm using. I'm gonna go from like 0 and so on. So I'm just gonna go 0, negative 1, negative 2, negative 3, negative 4, and we're just going to plug those all in. So now we're going to do it with negative 1, so it's going to be negative absolute value of x, and this time x is negative 1 plus 3 absolute value plus 2. And this right here, okay, -1 plus 3, that is 2, and then the absolute value of 2 is just 2, and we're gonna add in that negative symbol right there, so it's gonna be -2 plus 2, and we know that is 0. So the value for -1 is 0. Now I'm just gonna continue on just like that, replacing this x value, like this x variable, for whatever x value we're trying to input, and I'm gonna finish this table and we'll be back. So I solved for the rest of like the values, and I just want you guys to notice something. Do you guys see how we go like up and then back down? So the thing with the piecewise function, or like one specifically with an absolute value, is that it's gonna have like a kind of shape, if that makes sense. I just thought that was something important to notice. If you ever see a graph like this, it's like in this little shape, just know it's probably one of these. Okay, so now I'm just gonna plot all these points onto the graph and then we'll be done. Okay, so it should kind of be like common knowledge by now that I really can't draw straight lines that well. You know what? Maybe we'll have technology help me. Okay, hey, there we go. Okay, so that's the kind of like shape it's gonna have, the general shape. The reason for that is because we're using an absolute value. And so what an absolute value is literally doing is that it's just saying like whatever number you input, whether it be negative or positive, you're gonna get out the same exact number, because the absolute value means you sort of disregard whether it's a negative. You just get its like total complete value. So like if I give you -32, its absolute value is 32 because that's the actual value of the number, if that makes sense. So that's sort of the reason why it has this little like funky shape to it, which is a little different than what has been seen in like, or what has been shown in previous maths. Okay guys, but that's really it for this problem. Let's move on to the next one. Alrighty guys, so this is the last question that we're going over in this video, and this is question 15. So here we are asked, well, we are told, a local water agency models the water level of an irrigation basin with the function, all of this, h of t is the water level in feet and t is the number of months. Okay, so we already know that our output, aka h of t, is going to be equal to the water levels. So we can actually write this down on our little graph that this is water levels, and then it tells us that our input t is a number of months. So I'm just going to write that down here, number of months. Now, question 15 asks us, find h of 3 and explain what it means in the situation. So obviously we already know that since our input of t represents the number of months, we know that h of 3 just the water levels at 3 months, right? Because we know that our input t represents the number of months and our output represents the water level in feet. Let me specify that. In feet at 3 months. Okay, now how are we going to solve for h of 3? So we are given our function, right? And it says that h of t is equal to so it is negative absolute value of t minus 8, absolute value plus 12. So that is our little function. And we know that for h of 3, we're just going to plug in 3 for our t value. So let me okay, I'm actually going to use a wider color just because I want something different. Okay, so I'm just going to replace this right here with the number 3. Okay, and now we're going to solve for that. I don't know why I said 3 like that. I'm so sorry, guys. No, you know what? No. Let's be hyped for this, right? Let's be hyped for this math. Okay, and then I'm going to replace this right here with 3 as well. Okay, and then we're just going to continue to solve. So 3 minus 8, that is -5, question mark? Yeah, I think so. Yep, -5, and then absolute value of -5 is 5, but then we're going to add back on that negative sign, so it's going to be -5, and then we add in that plus 12. -5 plus 12 is 6. Okay. So this is just saying that h of 3 is equal to 6. So, what does that say? So after 3 months, the water levels are at 6 feet. And we can actually plot this right here on the graph. Let's see where we at. So we plugged in 3 and we're gonna put it at little 6 right here. Yeah, that's really it. So the main part of this question was just understanding that when you plug things in, even if you get out a negative, you're gonna get its absolute value, which is a 5. But since we have this negative out here, you're still gonna bring down the negative either way. But yes, this question was just seeing if you understood how to like understand the context of these problems, and also making sure you can actually like solve these absolute value functions. Okay, so that is actually a complete lie. It was not 6, it was 7. Oh, 6, 7. I'm so sorry. Anyways, it was actually 7. I don't know why nobody corrected me on that. Why was nobody like, hey Mariana, you're actually wrong? So sorry guys. This should actually be 1 up. 7. Okay, now that's your answer. So after 3 months, the water levels have reached 7 feet. Okay, so now that is our last question that we're going over in this video. If you guys still have any questions or there's anything you guys are curious about, feel free to comment, ask your teacher, or sign up for tutoring with Mu Alpha Theta. Anyways, that's it, and we'll see you in next week's video.